This is my solution for have you got it? So this is the interactivity we've got, and I have a list of variables over here: target, range, golden number, and smallest winning number. Let me explain them to you. The target, as you know, is the target we have to achieve by adding to the total, and n is the range of numbers I can add to the total. The golden number is such a number that if you take any number from, in this case, 1 to 4, then you can add any other number from 1 to 4 and get to that number and get to the golden number. And this is very helpful. I'll tell you how. The computer, I observed, was always defeating me when I got to 18. So when the computer got the total to 18, it means that if I would add any number from 1 to 4, like say 2, then the total would be 20, and then the computer could add any other number from 1 to 4, in this case 3, and get the target to 23. So in this case, the golden number is 23 minus 18, where the computer was defeating me, and that number is 5. Now let me fill in some of the variables. If you can add numbers from 1 to 4, then the range is 4. Golden number is 5. One simple way to calculate the golden number is G is equal to n plus 1. Now the smallest winning number is a number such that if we keep on going backwards from 18 by subtracting the golden number, we will hit such a number that is kind of accessible at the very start of the game. Let us find S. 23 minus 5 is 18, minus 5 is 13, is minus 5 is 8, minus 5 is 3. So 3 is accessible at the very start of the game. There could be other numbers like this, but the smallest value that is accessible at the start of the game is 3. So now we have all these 4. Now I'll tell you what to do with these 4 variables. So now, in this case, S is greater than 0. So I can start with playing a 3. Now the computer has played 1. I have this variable x1 over here. And x1 is the first move that the computer plays. And now I'm going to play g minus x1. 5 minus 1 is equal to 4. I'm going to play 4. And as you can see, 3 plus 5 is 8, which is another winning number. 12. x2 is equal to 4. I'm going to play 5 minus 4 is equal to 1. Okay. So the computer has played 2, and I'm going to play 5 minus 2, which is 3. Now what the computer has played 1. So I'm going to play 5 minus 1, which is equal to 4. Yes, I win. Now let us change the target and the range. Target is 27 and the range is 6. Let's change the variable suiting the case. A simple way to calculate S is divide the target T by G. The remainder is S. 27 divided by 7 is equal to 3, and we have remainder 6. So S is equal to 6. So now let us apply these variables in the same way. I'm going to start with playing of a 6. x1 is equal to 2. And I'm going to play 7 minus 2, which is 5. X2 is equal to 1. So I'm going to play 7 minus 1, which is 6. X3 is equal to 4. So I'm going to play 7 minus 4, which is 3. And yes, I win the game by applying the same strategy again. Now, there is a problem. What if S is 0? I cannot start with a 0. Let us try a case where S is 0. 32. So the target is 32. The range is 7 and G is 8. But when I divide 32 by 8, I get 0. Now the problem with 0 is I cannot start with it. So what I can do is, I just let the computer start. That is the equivalent of me playing 0. So I can say first to play blue. So now the computer has played something, and that something is x1, which is 7. So I'm going to play 8 minus 7, which is 1. X2 is 5, and I'm going to play 8 minus 5 is 3. As you can see, all the numbers we are landing on are multiples of G, which is 8. And that makes sense because we need to reach a multiple of 8. Again, so I'm going to play 8 minus 5, 3. I'm just going to play 8 minus 3, which is 5. And yes, I won. So, you have to look in such cases. Will T is T a multiple of G? So, we cannot say anything about any case whether it is best to start first or not. But for most cases, G is not a divisor of T. So, S is greater than 0, so it is best to start. By applying this very strategy, you can win even against the computer or any of your friends. Thank you.